The Wheel of Theodorus in Irrational Numbers. Concept: understanding rational and irrational square roots through geometry.
Hi everyone! Today, let's explore an interesting visual tool from ancient Greek mathematics, the Wheel of Theodorus, and learn how it helps us identify whether square roots, or radicals, are rational or irrational numbers.
The Wheel of Theodorus starts with a right-angled triangle where each leg measures 1 unit. Using the Pythagorean theorem, we calculate the hypotenuse, that's square root 2. This becomes one leg of the next triangle, and again, with a unit leg, the next hypotenuse is square root 3, and so on. Each triangle forms a new spoke of the wheel, growing outwards. You'll notice that the values go from square root 2, square root 3, square root 4, and so on, up to square root 17. Here's what we observe: square root 4 and square root 9 and square root 16 are rational numbers because their roots are whole numbers, 2, 3, and 4 respectively. But square root 2, square root 3, square root 5, square root 6, and others don't simplify to whole numbers, making them irrational. So, from this wheel, we can deduce radicals like square root 2, square root 3, square root 5, are irrational numbers. But when a number inside the root is a perfect square, like 4, 9, or 16, the result is rational. The Wheel of Theodorus visually demonstrates which square roots are irrational, a beautiful blend of geometry and number theory. The Wheel of Theodorus isn't just a beautiful geometric spiral, it directly models the calculations we use every day, often without even realizing it. TV and smartphone screens. When we say a TV is x inches, that refers to its diagonal measurement. Mathematically, this diagonal equals square root, width squared plus height squared. Since that sum often isn't a perfect square, the result is an irrational number, just like square root 2. This image shows exactly that diagonal line cutting across the screen. Engineering and technical drawing. In engineering drawings, accurate angles and diagonal measurements rely on square roots. For example, when designing frameworks or machine parts, the diagonal elements often involve irrational lengths for structural precision. This image shows such a technical draft, where every diagonal matters. So yes, the Wheel of Theodorus is more than a math curiosity, it's a visual model of real-life calculations in technology, construction, and design. It reveals the hidden presence of irrational numbers in our everyday world, making math not just abstract, but practical, precise, and essential.